Hey everybody, Mr. Grove here. Today we're going to talk about the phylum Annelida. So the annelids are commonly called the segmented worms, and first thing to note is there are about 12,000-ish. That number is not super huge to get hung up on, but what we do want to point out is that is way, way less than the number of mollusks that we talked about in the previous phylum. So mollusks are over 100,000, annelids are a little over 12,000. So some key points: they got a true coelom. That came up with the mollusks. So the mollusks had the true coelom, so do the annelids, and pretty much everything from here on out will have a true coelom. The other thing that is new with the annelids is the segmented body, and so that's kind of a big deal. This idea of body segmentation means that when we have repetitive parts, they can either A, work together, or B, kind of be replacements for others if certain segments were damaged. So you have segmentation. Many of the animals from here on out will have some sort of segmentation. Annelids also have a brain located at the anterior end, and then they also, with that segmentation, sometimes will have divisions internally as well called septum, and that's what you have. So your nose has a cartilage piece right here, and that separates the two nostrils, and we call that a septum. So kind of a similar type of terminology. The classes that we will use for the phylum Annelida are going to be the Polychaetes. These are the common earthworms, which you're probably used to the most. The Polychaetes, and then everybody's favorite, the leeches, class Herodinia. So let's take a look at some of the characteristics of the annelids. So like we said, they do have a full fluid-filled coelom, and that will add in the efficiency of moving nutrients around. We also have really specialized organ systems, and so we're going to have a closed circulatory. Remember, only the cephalopods had that. We're going to have a complete digestive. So that means they can really efficiently get nutrients out of the soil that they're eating. We're going to have nephridia. We're going to have a nervous system. So lots of good systems. We also are going to have some things called setae. And so these setae are these little bristles here. And that gives the earthworm traction as it goes through the ground. Also kind of a little defensive. If you've ever tried to pull an earthworm out, those setae really kind of stick in. Some annelids will have parapodia, this little fleshy appendage that then the bristles are on. So Polychaete does not, but the Polychaete will. And then our skeleton is what we'd call a hydrostatic skeleton. And so with that, it's going to be kind of fluid-based. There's no crunchy exoskeleton like with insects, and there's no internal bone structure either. Muscle-wise, we've got these circular muscles here, and so those will squeeze down, and as those contract, then that will make the worm go longer. And then we have these long longitudinal muscles that run the length of the worm. And so as those contract, that causes the worm to inch up. So you get kind of that inchworm effect. So let's take a look at the very specific classes. And so the first one is the Polychaetes. So these are going to be the marine worms. Note that about 8,000-ish is going to be our number. So about 2/3 of all annelids are going to be Polychaetes. So they live in the ocean, salt water. They also have parapodia, so that's these little fleshy appendages here. And then the bristles, the setae, will be on the outside of that. Some will be free swimming, so like this narcissus. Some will be kind of build these little tubes and live in them, so like these little Christmas tree worms or feather duster worms. And those guys are just going to filter food out of the water. So that's the Polychaetes. One way you can remember that is the Polychaetes live in the ocean. Pirates are in the ocean. Pirates have parrots, and parrots say, "Polly want a cracker." I know it's dumb, but sometimes the dumber it is, the better it sticks in your brain. So class Polychaete. The one that you are probably most familiar with is going to be class Polychaete, and these are the earthworms. So no parapodia, but they do have the bristles, the setae. No eyes, but we do have light-sensitive and touch-sensitive organs. So when you touch a worm, it starts to wriggle around a little bit. They also have moisture-sensitive organs. So, I mean, worms will go towards the moisture. So if it's been a rainy weekend, lots of worms will go up to this top and be on a sidewalk or something. If it's really dry in the summer, then they're going to go deeper. They're going to eat their weight in soil about every day. And so that soil, literally they're eating dirt, will go in through the mouth. It kind of gets stored in this little container called the crop. And then the gizzard is a little bit more muscular, and it will start to crush that soil up a little bit, and then starts the slow digestion all the way through the intestine, and then it gets pooped out the anus. And earthworms are really good for soil, so that's a positive thing. If you're digging in your garden and you got a lot of earthworms in there, that's a good thing. That helps with anti-compaction on that. So that's the class Polychaete. Probably the largest one of those is this Gibson earthworm. That is not a Bond County thing, but that is found in Australia, and they can get up to 6 feet long and sometimes estimated to live up to 20 years. And so that's the largest of the Polychaetes. And then lastly, we have the Herodinia. So this is the leeches. Notice we're down to under 1,000 species, so there's just not a whole lot of these guys. But they do have suckers at both ends, so an anterior sucker and then a posterior sucker. And so that posterior sucker is to kind of attach to rocks or whatever, and that will allow them to kind of dance back and forth like the weeds and the grass in the water. And then that anterior sucker, which would be right here, acts like a mouth. And so then that hooks on to a suspecting fish or mammal. They will suck their blood, and they can eat up to their body weight times 5, 6 in one setting of blood. So they'll gorge so much that they won't even be able to, really move. And then that might last them a few months until they have to be ready to feed again. So no parapodia, no fleshy appendages here, no setae, no bristles. They don't really need the traction in the water. Parasitic, although they will scavenge a little bit too. The segments that aren't internally divided, they are external segments you can see, but not internally. And so a lot of these guys will have like some alternative medicine uses. So in alternative medicine, Eastern medicines, they'll use leeches to try and get rid of kind of bad blood. And interestingly enough, a lot of times they'll use turmeric powder to get the leeches to basically vomit up the bad blood so it doesn't damage the leeches. So definitely, I'll stick to my antibiotics, but I know it is a possibility out there. And that is the class Herodinia. So that is the annelids. And don't forget to smash that like button, and I hope that was helpful.